this time, then we're going to push the schedule. So, are they successful systems? And that's a pretty hard thing to just kind of say off the cuff, but Boeing had several $billion in cost overruns in order to meet their development schedule. And they spent those, and they took a lot of heat at the time for going over budget. A couple of details I can give you is that the selling cost for a 777 now is about $250 million, and I don't know what it costs to manufacture, but you can bet that there is a profit margin in there, so it costs less than that to manufacture. Don't forget that the cost to manufacture also has to include all of the development costs, and so there were somewhere between $10 and $20 billion spent to develop the Boeing 777, and they have to recover that over the years and the units that they produce. I think I mentioned 950 have been built, 300 are on order. This is really considered a cash cow in these days for Boeing because that's a very well-developed manufacturing process. They're selling lots of them, they're building lots of them. So in terms of current day, Boeing is now gaining back its investment, and they see it as a money maker for the years to come. In terms of reliability for the airplane, they've had one hull loss, which was a fuel starvation issue that happened in the UK. The airplane actually made it to the airport and crashed just before the runway, and there were no fatalities in that. For the Air Force, so it took them more than 15 years to develop. So you might say it's almost a decade late. They had billions in overruns, and I think I mentioned it's kind of a well-known, often joked about program that they went on and never met their schedule requirements. I did find that the unit manufacturing cost is in the order of just under $200 million. It's not a commercial product that I know the price of, so I don't know what they sell them for. But don't forget also they have to incorporate the billions in development costs have to be amortized over the number of units sold. And only 230 have been built to this point right now. They're down to building about 10 a year. It's considered that the technology on board was obsolete by the time it was delivered because it took so long to be delivered. The U.S. program is being phased out, so the U.S. government says we no longer want to buy any C-17s. The only way that Boeing is continuing to produce them is that they're having international sales. And because it is a military system with such high performance, they have to get approval to every country that they sell to. So that's a bit of an issue in terms of having a market to sell the airplane to if the government doesn't want it anymore. In terms of reliability, they did have one hull loss in the summer of 2010 with 4 fatalities. They've pretty much determined that that was a pilot-induced stall close to the ground and it was not able to recover. So probably not an equipment issue, but human factors problem. So to kind of summarize here, if we look at just this data point of a Department of Defense systems engineering effort versus a commercial systems engineering effort, we could say pretty clearly that we're talking in 2 different contexts here. It's a very different mode to develop for the U.S. government than it is to develop for yourself and a commercial market that you're trying to meet the needs for. You could say in terms of performance versus profit, the government and the military and the Air Force specifically, they have very specific performance requirements that they care about and they want met in terms of military requirements, and they don't much think about the other aspects of the whole system. Boeing, on the other hand, they have to turn a profit. So in order for them to turn a profit, they have to deliver an airplane that the customers are going to buy again and again in terms of the airlines. So part of that balance and that effort is Boeing with the 777 took a very conservative view of technology that had to earn its way onto the airplane. Just because it's a neat, nifty, high-performing capability, if it doesn't make business sense and it's a high-risk technology, we're not going to put it on board. The Air Force, on the other hand, they said we're going to use the latest and greatest off-the-shelf technology. We're going to push that to make McDonnell Douglas use these, and they had some real issues with that. So that was a different approach to how they implemented technology in the system. The Department of Defense and McDonnell Douglas was a very audit-centric environment where everything had to be documented. The government was always on site investigating costs and times to develop and things like that. That documentation had to go through Congress to justify spending for it. So it's a very regimented, audit-centric environment, whereas Boeing says, we're not responsible to anybody but ourselves. We'll use the part of the systems engineering process that meets our needs, so we'll put the right pieces of systems engineering together to meet what we need for it to do. The funding source at Boeing, it's all internal. They take the risk of developing the system with no for sure sales versus a McDonnell Douglas situation where they're going to bid on the contract, they're going to count on the money coming from the U.S. government and Congress, and that's just a very different environment than funding it yourself. The way they responded to issues or problems they had during the development program, Boeing said, we're going to open the checkbook and we're going to push to meet the deadline, because the sooner we get that out to the market, the sooner we're going to start making money off of our product. When they had problems on the C-17, Congress and the government gave them a real hard time. They said, well, if you're not going to meet the deadlines for the funding, then we're going to reduce your funding and we're going to push the schedule out and prolong it a little bit. So it was a very different response to how they dealt with problems they had along the way. And really, in my mind, it all comes back to the effort and the extent to where they established what the requirements for the system were going to be. Boeing went to great lengths and lots of effort, time, and money to identify really what the customer wanted. On the other hand, the Air Force said, here are the military capabilities we want. Make a system to do that. And either McDonnell Douglas didn't do it, didn't realize they needed to do it, or the Air Force didn't let them, but they weren't able to get to the depth of requirements discovery to really see what the airplane capabilities needed to be in order to be a successful system. So that's really in my mind, the difference in the efforts was all the way back at the requirements discovery process was, did they do a really good job? Of course, it's not that simple. It's a very complex issue and all these other things are going on. But there is kind of one snapshot of two similar systems that were developed in very different environments. One being a very rigorous acquisition-based government organization, and one being a for-profit private commercial organization. All right, I hope that you enjoyed seeing just a snapshot. See you again.